This is Rohini Bawa from Chandigarh Polytechnic College, and today we are going to discuss the architecture of MODEM. I'm working here as an assistant professor in electronics and communication engineering. We already discussed modems, and today we are going to discuss about the architecture of modem and its interfacing. So today we are going to discuss about the modem architecture. If you have any queries, then you can ask me up at the end. And I'm going to share a screen with you all so that it will be helpful in your further studies. So this is the modem architecture. In previous lectures, we already studied that what is the in the previous lectures we already studied that about modem. So what a modem is. In this video, in this lecture we are going to study about the modem architecture. An analog modem converts the digital signals from computer to analog signals that are transmitted over a voice-grade access to the PSTN. Here on the screen, on your screen, here is a diagram of modem architecture, which can be controlled with the help of a data pump. Here in this, there are different blocks, that is controller, terminal interface, UART, receiver, transmitter, DSP, AFE, and DW. And at the last, the signal goes to the PSTN. So PSTN, here it is, let us study with the different blocks. First one is modem architecture. Here it is the data pump. Data pump is responsible for carrying out two primary functions of the modems. That is, once we give its name, first one is the modulation and second one is the demodulation. In the modulation part, it is a conversion of the digital bit stream received from terminal into an analog signal that is sent over a telephone line. And in case of demodulation, the conversion of analog waveform received over the telephone line into a binary data that is sent to the terminal. The data pump is commonly viewed as the engine of the modem, and a typical data pump is comprised of two main functional units or subunits, we can say. First one is AFE. So AFE stands for analog front end. Here it is AFE in between the A to D converter and D to A converter. So it is the analog front end. It is digital to analog converter converts, and analog to digital converter converts the voltage on the phone line to discrete binary values of the digital signal processor to process. The D2A converter converts the binary data from the DSP unit and smooths the output to form an analog signal. Next block is our DSP, that is a digital signal processor. It is a specialized processor that is optimized for various signal processing functions. Most important that it executes in a real time the mathematically intensive operations involved in the executing the different modulation and demodulation algorithms for the various modern protocols. It also handles echo cancellation, tone generation, and some other specialized functions. Next one is our controller. The work of controller is to handle the command interface to the terminal, and some interpretation and execution, performs error correction in data compression algorithms, handles flow control between the terminal and data pump, and various other supervisory and miscellaneous functions. So the controller is often referred to the CPU of the modem. Next one is our DAA, that is a data access management, which contains the analog circuitry, electrically isolates the modem from the telephone network, and also provides some physical interface like line impedance, hybrid circuitry, and so on to connect to a plain old telephone system line. And next one is our terminal interface, the asynchronous serial interface between the modem and the terminal. The section terminal to the modem communication we can do in the later chapters, which covers the transmission of the protocol that is RS-232, which is used for the interfacing, and some asynchronous character framing that occurs on the connections. So let us start with the modem modulations. We already studied that is the basic type of modulation used in the modems. First one is our FSK, second one is amplitude modulation, third one is phase shifting, fourth one is QAM, that is quadrature amplitude modulation, fifth one is DCM. So FSK, AM, PSK and QAM we already studied in our previous lectures. Now let us discuss the trellis coded modulation, that is our DCM. It is a modulation scheme that transmits the information with a high efficiency over band limited channels such as telephone lines. PCM is used to the convolutional code to generate the redundancy necessary to the achieve a coding gain while preventing bandwidth expansion by increasing the size of constellation rather than the number of transmitted symbols. TCM attempts to improve QA and it goes beyond a simple modulation whereby bits, code words, and simply mapped to the signals. Now let us start with the interconnection or interfacing of the modem. So the modems differ according to the method of interfacing with the communication circuits. If the circuit is short and a dedicated line, a limited distance modem can be used. This type of modem can be relatively simple in its circuitry since it doesn't have to derive a line which utilize the switching systems and line control devices such as the echo suppressors. On your screen, there is a figure shows. Here it is a business machine. It's like a ATM or something else. And here it is a modem, modulator section and a demodulator section. Modulation section goes to the next modem. It provides some signals with the help of some wired or a non-wired meter. Depends upon our modem or our specifications. And next here it is in the second part or a receiver end we have a modem which contains a demodulator and modulator which provides the signals to the computer. Next is our modem interfacing, which is the most important part in our in our communication. The concepts we use two concepts as that are very important for understanding. That is DTE and DCE concept. Now, what is the DTE? So DTE stands for the data terminal equipment, and DCE stands for the data circuitry equipment. So the communication link between the terminal and modem divides into three links. First one is here RS-232, that is a physical layer, which defines the mechanical, electrical, hardware signaling used to the terminal to modem cable. Second one is our asynchronous framing layer, which specifies the format used to frame characters on an asynchronous link. Next one is command layer, and it's a command language used by the host to configure and control our model. From the point of view of the standard, the modem is known as data communication equipment, which we are already told you that is a DCE, and digital equipment to be connected to the modem is known as a DTE, that is data terminal equipment. Now there are various international standard bodies that are agreed on the specifications that detail how to facilitate the connection of data communication equipment. These standards discuss the interface between the DTE and DCE both. The specifications describe the physical and electrical interface between the DTE and a particular type of DCE. So the DTE is the equipment that acts as a data source or a link from point of view that it converts the user information into the signals to be transmitted by the DCE. The most frequently used examples of DTE is a computer and DCE equipments that establish and provides the access to the communication link over a channel connecting the source and destination, that is DTE. A DC provides a data link service for DTE to communicate over the DCE. So here this figure shows that logical location and the function of both DTE and DCE. The practical significance we can say is distinguished between this two types of equipments is that they are pinned and cabled differently. Now, starting with the interfacing. So, RS-232, it is a serial transmission system which is designed to support the communication for very short distance between the DTE and DCE. Because of the RS-232, it was intended for the DTE and DCA links. Therefore, its functions are very largely those needed to for controlling of the model. A standard that is RS-232 link will use the DB25 connector, which is a DTE port is a male one and the DCE port which is a female one. So we are going to discuss about it in the next slide, that what is a male and a female connectors are and how many pin it contains or how many bit it contains. So the data circuit terminating equipment is a device that provides the interfacing between the DTE and the network, and it is often a modem or terminal adapter. And RS-232 is compatible interface, which is commonly used for the computer serial communication ports, which were originally intended for the connecting from the computer to a modem. So let us discuss, starting to discuss, that is DTE or DCE or a 232, RS-232 or DB25 male shield and a female shield. But before goes to the male and female part of the shield on the DB25 and DB9, the RS-232 connector was originally developed by using 25 pins. In this DB25 connector, pinout provisions were made for a secondary serial, that is RS-232 communication channel. Only one serial communication channel with a campaign handshaking is present only. And a very few computers have been manufactured where both serial RS-232 channels are implemented. The pin out is also shown, that is a DCE modified modular jack. This type of connector has been used on systems built by the DEC, that is a Digital Equipment Corporation, in the earlier days. And a serial interface is a differential transmit over their own floating ground, which is not the case of regular RS-232. It is possible to connect RS-232 which is compatible devices with this interface because the voltage levels of the bit streams are in a same range, where the RS-232 will be focused on the connection of DTE. And now let us discuss about the RS-232 and DB25 shield. In this, here we are having 25 pins. First pin stands for the shield. Second pin is for transmitting data. Third pin is for receiving the data. Fourth pin, request to send. Fifth is clear. Sixth one is that your DCE is ready. Seventh is ground. Eighth one is receive line signal detection. Ninth and 10th will be reserved for testing. 11th is unassigned. 12th one is received a line signal detect. 13th one is clear to send. 14th is the transmission of data. 15th one is our DC sources, which will be transmitter, which is used for the transmitting side. 16th one is reception side. 17th receiver, that is a DC source. 18th have local loopback. 19th request to send. 20th DTE is ready. 21 remote loopback. 22 is ring indicator. 23 is your data signal rate selector. 24 transmitter signal timing. It is on side of DTE. And 25th is on our testing mode. So the RS-232 does not specify the bit rates. We can see here that RS-232 does not specify the bit rates. However, for asynchronous transmission, the following rates have been typically seen, that is 50, 75, 110, 150, 300, 600, up to so and so. BPPS. And as specified in the standards, RS-232 is officially considered to be suitable only for data rates up to 20 kbps, which will become in your exams for a one mark question, that what is the data rate of RS-232 connector, that it is 20 kbps and its distance is up to 50 feet. The RS-232 is often run at 11,000 and 2200 bps for the distance up to 20 feet, and at 9600 bps for a distance at as much as it may be 500 feet. So the protocol, RS-232 protocol, defines 9 electrical signals, so 9 electrical circuits to handle all the handshaking between the DTE and DCE. These electrical circuits are also referred to as, we can say, leads, pins, or signals, which will be grouped into three categories. First one is data interchange circuit. Second one is control interchange circuits, and third one is our ground circuit. So data leads are used to signal the exchange of data. And these circuits are defined on your screens, that is the RS-232 circuits and their functions. So these leads, data leads are used to signal the exchange of data. Ground leads govern the call signaling states between the DTE and DCE and manage the flow of control between them. As the name suggests, the ground leads the reference ground for the DTE and DCE port. So this is about the circuit of our RS-232, and we can see the circuits and their functions. So here it is the ground, signal ground reference. It is used for the reference one. Second one is for the data, that is transmission and reception. Control case, that is a modem control. And both one is TR and DRS, that is the data terminal will be ready, and it is raised by when that it gets the data access to the DCA link, and the modem will not dial unless it sees the DDS. And for the case of data set ready, that is DRS, it is released only when it is powered up and in such a state where the communication channel is available for the transmission and reception. On the case of CBT and RI, that is a carrier detect and a ring indicator. So it is raised by a local DCE when it detects a carrier signal from the remote DCE. And ring indicator, it is raised only when in the signal to the DTE and there is an incoming call. When there is an incoming call, RI is in accordance with the incoming ring, for example, a phone line, we can say. And CTS, it is clear to send, and RTS, which is used for request to send. And RS-232 protocol defines the 9 electrical circuits for handshaking between the DTE and DCE. These electrical circuits are grouped into these categories that we already discussed: data interchange, control interchange, and ground circuit. And data leads are used to signal to exchange of data, that is control leads governed by the call signaling states between EDE and DCE manage the control of loop between them. So it's all for the today. If you have any queries, then you can ask me up.